In this lecture, we're going to learn about microservices. What are the main benefits of having microservices application and what you as a DevOps engineer need to know in order to be able to deploy microservices application in a Kubernetes cluster. At the very beginning of the Kubernetes module, you learn that Kubernetes emerged as a platform for microservices applications. So basically, the traditional big monolith applications evolved into applications that are made up of multiple smaller applications that can be developed and managed and also deployed independently of each other. For example, if we consider big complex applications like LinkedIn, you may have one microservice for user account, another microservice that has all the logic for the messenger, another one for job listings, yet another one for blogs, etc. So usually each business functionality is encapsulated into its own microservice. So you have smaller applications instead of one giant application that developers manage. And the major advantage of this is that each microservice can be developed, packaged, and released independently. Developers can make changes in one microservice without ever affecting any others. You have cleaner code and less interconnected logic. If developers mess up something in one service, all others will be unaffected by that. And in practice, it often happens that each microservice can even be developed by a separate developer team. Now, you're probably wondering if microservices are independent of each other, if there is no code connecting them, how are they part of the same application? Because components of an application obviously need to talk to each other, right? Like how would a user account microservice in LinkedIn connect and talk to a messenger or a blog post microservice? Well, there are different ways how that happens. One way microservices communicate is through interfaces or APIs, which is basically a code with a bunch of functions inside the application itself, which is responsible for handling communication with other services. So the logic or code for talking to other services is inside the microservice itself. Another way of communicating is where the microservices talk to each other through a third-party message broker application. So instead of each service sending requests to all the others, all microservices talk to the message broker saying, hey, can you send this request to this microservice, please? And the message broker then manages the communication between them. This means less code complexity inside the microservices. Some popular examples of message brokers for microservices are Redis or RabbitMQ. Another architecture that is also becoming more and more popular in Kubernetes world is a service mesh, where instead of one central big message broker that handles all the communication, each microservice has its own helper program that handles the communication for that specific microservice. So microservice user account says, hey, my helper program, can you deliver this request to microservice messenger? And the helper program, or in Kubernetes world, a sidecar container, will then send it and deliver it to the helper program or a sidecar of another microservice. And one of the most popular service meshes currently is Istio. Now, microservices application development can be pretty complex. So you're probably thinking how much knowledge and understanding you specifically as a DevOps engineer need about microservices to be able to do your tasks or to do your job as a DevOps engineer. So basically, what part of microservices is your responsibility? Usually, when you are a DevOps engineer, you will get a task to deploy an existing, already developed microservices application in the cluster. So developers have already created and developed these microservices, and they're asking you as a DevOps engineer to please take these services and deploy them in a Kubernetes cluster. At this point, it's important to know what information you need from the developers about these microservices to be able to deploy them in the cluster. So let's go through this information one by one. First, obviously, you need to know what are all the microservices you need to deploy and how are they communicating with each other. So which microservice is talking to which other microservices. You also need to know how they communicate. Are the services communicating directly using the APIs or using a message broker or a service mesh? And in case of message broker or service mesh, you want to know which application exactly they are using, as well as which database are they using, and so on. So all the third-party services basically that these microservices depend on to run successfully. Also important information is on which port does each microservice run. Using this information, now you can go and prepare the Kubernetes environment by deploying any third-party services that these microservices depend on or creating any secrets and config maps for the services. And then once the environment is prepared, then you go and create Kubernetes manifest files for each microservice. This will be deployment and service components for each microservice. And you can also decide whether these microservices will run in the same namespace or each microservice will run in its own namespace. Now that you understand the main concepts of microservices and what information we need as DevOps engineers to deploy an existing microservice into the cluster, we're actually going to do that using our next hands-on demo project. So we're going to take an existing microservice application, which is hosted on a Git repository, and we're going to deploy that inside a Kubernetes cluster.